So there's a third case that we have to carry out, which is the exceptional case, namely the integral of dx over x. And this time, if we just think back to what our, so what we're doing is thinking backwards here, which is a very important thing to do in math at all stages. We got all of our formulas, now we're reading them backwards. And so this one, you may remember, is the natural log of x. The reason why I want to do this carefully and slowly now is right now I also want to write the more standard form which is presented. So first of all, of course, we have to add a constant. And please don't put the parentheses here. The parentheses go there. Okay. But there's another formula hiding in the woodwork here behind this one, which is that you can also get the correct formula when x is negative. And that turns out to be this one here. So I'm treating the case x positive as being something that you know. But let's check the case x negative. In order to check the case x negative, I have to differentiate the logarithm of the absolute value of x in that case. And that's the same thing, again, for x negative as the derivative of the logarithm of negative x. That's the formula when x is negative. And if you carry that out, what you get, maybe we'll put this over here, is, well, it's the chain rule. It's 1 over negative x times the derivative with respect to x of negative x. So see that there are two minus signs. There's a minus x in the denominator, and then there's the derivative of minus x in the numerator. That's just negative 1. This part is negative 1, so this is negative 1 over negative x, which is 1 over x. So the negative signs cancel. If you just keep track of this in terms of log negative x and its graph, that's a function that looks like this for x negative. And its derivative is 1 over x, I claim. And if you just look at it a little bit carefully, you see that the slope is always negative. Right? So here, the slope is negative, so it's going to be below the axis. And in fact, it's getting steeper and steeper negative as we go down. So it's getting less and less negative as we go horizontally. So it's going like this, which is indeed the graph of this function for x negative. Again, x negative. All right? All right, so that's one other standard formula. And very quickly, very often we won't put the absolute value signs. We'll only consider the case x positive here. But I just want you to have the tools to do it in case we want to handle both positive and negative x.